On this 2019 through 2025 Ram 1500DT with the 3.6 Pentastar P0352 points to the ignition coil 2 primary control circuit. In plain terms, the PCM is watching the coil 2 signal circuit, and this fault can set when that circuit current is less than or equal to 0 amps for at least 2 seconds. The monitor runs continuously with the ignition on, and the MIL will illuminate. The truck may misfire, run rough, have reduced power, or in some cases only show the light. The broad areas to keep in mind are the fused relay output feed, the coil 2 control circuit, the ignition coil and plug area, connector integrity, and the PCM driver. Start with the basic system checks, then follow the circuit path in order. First, use the scan tool to read DTCs in all ECUs and record them, along with the related operating data. Save a full vehicle scan report for the job record. Then erase all DTCs, turn the ignition off for a minimum of 0 seconds, turn the ignition back on, and operate the vehicle under the same conditions that set the code. Read the DTCs again. If P0352 does not return, treat it as an intermittent condition and do not guess at parts. If it does return, continue with the diagnostic path. Next, look at the DTCs you recorded. If any ASD-related faults are present, handle those first, because a shared power feed issue can lead you down the wrong path on an individual coil circuit. If no ASD faults are present, move on to the relay output feed test for coil 2. Now isolate the 12-volt supply circuit by disconnecting the component harness connector. Connect the positive lead of the load test tool to the 12-volt supply circuit at the component connector and connect the negative lead to battery ground or a good chassis ground. Make sure the circuit is actually powered during the test. If it is an ignition feed, the ignition has to be on. If it is relay output, the relay has to be energized. Use a real load, not just a high impedance light. A 3156 bulb has approximately 6.0 ohms of resistance and draws approximately 2.0 amps of current. A high impedance test light drawing less than 0.1 amps can miss resistance in the circuit, so the tool being used should draw more than approximately 0.75 amps. The load test bulb should be illuminated and bright. If you voltage drop it, compare the voltage across the bulb to battery voltage, and compare bulb brightness to a direct battery connection. As an example, 2.0 ohms of resistance in the circuit being tested can make the voltage across the bulb 25% less than battery voltage because the total circuit resistance becomes 8.0 ohms. If the bulb is not bright, repair the 12-volt circuit for an open or high resistance. If the fuse is open, check that circuit for a short to ground. Then verify the repair and confirm the code stays gone. If the feed circuit load tests good, check the coil 2 control circuit. Keep clear of the fan, pulleys, belts, and loose clothing anytime the engine is cranking or running. Use a 12-volt test light connected to a 12-volt source and probe the coil 2K17 control circuit at the ignition coil harness connector. Crank the engine for 0 seconds while watching the light. A bright blinking light sends you toward the plug and coil secondary side checks. A light that stays on constantly sends you to a short to ground check on the control circuit. A light that stays off constantly sends you to an open or high resistance check on the control circuit. When the control circuit is blinking correctly, turn the ignition off and inspect the spark plug for the listed physical problems: cracks, carbon tracking, foreign material, gap size out of specification, and a loose or broken electrode. If one of those conditions is present, replace the spark plug. If carbon tracking is found on the plug, inspect the ignition coil boot for damage and replace the boot if necessary. Then verify the repair and confirm the code stays gone. If none of those plug conditions are present, replace the ignition coil and spark plug, then verify the repair. If the test light stayed on constantly, isolate the coil 2K17 control circuit and check it for a short to ground. The ignition must be off when checking continuity to ground. Disconnect the ECU and every component connector that contains the circuit being tested, then follow the circuit path connector by connector. Put the DVOM negative lead on a known good ground and probe the circuit at the component connector with the positive lead. There should be no continuity between ground and that control circuit. If continuity is present, repair the short to ground, then verify the repair and confirm the code stays gone. If there is no continuity, continue to the coil and PCM driver check. If the test light stayed off constantly, isolate the coil 2K17 control circuit and check it for an open or high resistance. The ignition must be off when checking circuit continuity. Disconnect the ECU and the component connector for the circuit being tested. Before measuring the circuit, touch the DVOM leads together and note the meter lead resistance, because the leads can add resistance to the reading. Measure from the circuit at the component connector to the same circuit at the GPEC adapter. Do not probe the PCM harness connectors directly. Probing those terminals can damage them and create poor terminal-to-pin contact. If a PCM connector terminal has to be accessed, use the GPEC Diagnostic 10436 adapter. Also remember the GPEC Diagnostic adapter can add up to 1.5 ohms of resistance to the circuit. If the circuit resistance is below 3.0 ohms, move on to the coil and PCM driver check. If it is not below 3.0 ohms, repair the open or high resistance, then verify the repair and confirm the code stays gone. Before condemning the PCM, make sure the ignition coil is not the cause of a PCM coil driver failure. An internally shorted or damaged secondary coil circuit may be the reason the driver failed, so do not replace the PCM without checking this. Remove the ignition coil controlled by the driver that's set P0352 and install that coil in another coil location that did not have a fault set against it. Turn the ignition on, erase DTCs, then start and run the engine for up to 1 minute. If the engine will not start, crank the engine 3 times for 10 seconds. Read DTCs again. If a correlating fault sets for the new coil location, replace the ignition coil, replace and program the PCM, then verify the repair. If no correlating fault sets for the new coil location, move on to connector and terminal checks. At this point, handle any applicable bulletins for the condition, then inspect the related connections. Disconnect the PCM harness connectors, any related inline connectors if equipped, and the related component connectors. Look closely for improper connector seating, damaged locks, corrosion, water intrusion, seal damage, bent terminals, signs of overheating from a poor connection, terminals pushed back in the cavity, spread terminals, and weak terminal tension. Repair any condition you find. Reconnect the PCM, inline, and component connectors, making sure they are fully seated and locked. Erase DTCs, then test drive or operate the vehicle under the conditions that run the monitor. Read DTCs again. If P0352 returns after those connection checks, replace and program the PCM, then verify the repair. If it does not return, the wiring or poor connection problem has been corrected, and you still finish with repair verification. Keep the verification step separate from the testing. After any circuit repair, plug or coil repair, connector correction, or PCM programming, clear the codes, operate the vehicle under the monitor conditions, and confirm P0352 stays gone. The main takeaway is to prove the feed, prove the coil control response, separate plug and coil problems from wiring problems, and do not condemn the PCM until the coil and connections have been checked. For more diagnostic training, visit stepdiagnostics.com.